The 1999 movie Office Space is a bit of a cult classic, features many memorable lines and scenes, and can also teach us a little bit about game theory, and in particular, traffic congestion and how to think about it as what we would call an N-person game. Let's go ahead and watch the introductory scene from Office Space right now. So in this scene, we see that Peter cannot seem to choose the correct lane of traffic. And it's just amplified by seeing the person with the walker continue to gain ground and make better progress on, the quote-unquote commute into work. So how does this actually relate to game theory? Well, within game theory, the most commonly studied game would be a two-player game. You have two players, but then, there are also three-player games, but eventually you get to so many players that it gets tough to distinguish and say, like, what do you do with a seven-person game? And everybody has different decisions. It actually gets really too complicated too fast. But there is a way to simplify with what's called an N-person game, where N just indicates that it is a large number of individuals, and the large number of individuals, we can simplify the game by doing a couple things. One, we assume that there are representative agents, so that there are a certain, maybe you have 10,000 people, but these people generally have a set of preferences or maybe two sets of preferences. So you can kind of split apart. A representative agent, they behave in a particular way, or maybe they behave in multiple ways. Now in this case, with traffic, you often assume you have agents and their goal is to minimize commute time among the different routes that you could take. And then also, in order to solve for N-person games, you need what's called a state variable, which is just a way to explain what is the current situation within the game, or, game theory really studies issues within the world right now. So what is the current state of the world right now? How does this relate to traffic? Well, when people have a commute, if you have one possible route only into work, okay, there's no game. This doesn't apply at all. But if individuals have multiple routes into work, what route could be quicker? And does that vary based on how many people are already taking the specific route? Often the answers to these are yes, and then N-person games become applicable. So where it really matters is if you have, let's say you have a couple different routes. One is on a route that will always be the same length every time. Perhaps it never backs up, but maybe it's a little bit longer. And then maybe you have another route that could be shorter if there's not many people on it, but could be longer if there's too many people on it. Well, game theory ends up predicting that as long as there's enough information out there, the routes should be approximately equal in how long it would take for everybody to get through things. Now, what becomes interesting, right? I said if information is available and equal. that's often not the case. I know personally I'll drive into New York City sometimes, and the route we take is through the Lincoln Tunnel, and wow, it can really vary wildly if you do not know what lanes to be in at certain times. There's a certain time going to the Lincoln Tunnel where if you are not all the way over in the left lane, you're going to get stalled because people want to exit. And when you get right next to the Lincoln Tunnel, the different lanes can also move at different speeds. This is something that in theory, right, if everybody has perfect information, that shouldn't happen, but information isn't perfect. So there can be ways to exploit the game in an n-person game dealing with traffic if you have better information. One fascinating thing is to think about how have apps like Google Maps and in particular Waze impacted this n-person game. There are times where if you are driving on a long trip, or maybe even not a long trip, you might plug in something to your GPS and there will be a route, but GPS will say, whoa, there's an accident. You can save 7 minutes by taking this different route. Well, that might be true unless every other GPS starts rerouting people on a particular route. And then you could run into the same situation Peter ran into when he was constantly changing lanes only to get stalled and make worse progress on his commute. So it's a fun little scene within Office Space, but it gives a chance to talk about a somewhat complex topic within game theory, the idea, how do you solve for n-person games? N-person games can also happen when there are different options for how you queue, how you might wait in a line. Are there options for paying for premium line passes at parks like Disney World, Disneyland? Game theory and n-person games could apply to that and to a number of other situations. My name's Matt Rosu. I am doing a series now with game theory, the class that I'm teaching in the fall 2023 semester. If you like this, please click like, subscribe, and hit the notifications bell. You'll keep getting, you'll get notifications when new videos drop. I look forward to seeing you in the next video.